I'm not done with what I'm doing, but I was not going to videotape this until I just came across such a ridiculous number of barriers and effort in order to make something easy. So, water line replacement. Originally it was wooden buckets, right? But in more recent times it was steel pipe replaced by copper pipe, now being replaced by PEX, each time going bigger and bigger. So 1/2-inch copper is what it currently has. You can see it there disappearing into the wall. And this first part of the digging was trivial, easy. Multiple phone lines and cable lines come into the house, none of which are used, and are all redundant, but digging around them. Came to the driveway, and at first it wasn't too hard, but then it became just absolutely impossible. So that was day one. Day two, got the jackhammer, came back with a small jackhammer that I can get in there to erode the concrete I came across, to figure out why it's there. And I've found a number of interesting things, perhaps only interesting to me. Large hunk of concrete, which I've not yet discovered the purpose for. A footing for some building at some point in time. Concrete, so obviously more recent than Roman times. No idea what it is. But then I came across curiosities such as 3-inch thick layer of stone, which I put down. Clay, 6 inches of clay impregnated with brick, packed hard, which was there before I started messing. Then a short layer of topsoil, very thin layer of topsoil, and then stone. And I've come across compacted, very hard stone. So I'm picking away. I will not be defeated, and eventually I will get this new water line in. Trench is finally done. That concrete was nothing. It's just the footing of some kind of shed or other that has unknown history. I found the steel pipe. I found the copper pipe. Copper pipe is the same depth that I've dug. Steel pipe was about 6 inches below grade. The box is 20 inches. So the trench is 24 inches. I have to go 6 inches below the frost line. The frost line in these parts is quoted at 12 inches, so 18 inches would be sufficient. But I've gone 24 only because every inch is a struggle. And if it was easy, I perhaps would have gone deeper. But now I have to dig through in the box, disconnect both ends of the pipe, and start playing with my new pipe. I had no intention of this being a multi-part video, but holy crap, this is kicking my behind. Anyway, the pipe is into the house, into the original hole, and that was silly. I could have cut another hole and made my life a lot easier, but it is in the house and is 22 inches down. Trench is all good. Pipe is sort of loosely in for tomorrow, because right now I don't have the energy to hook it up to where it has to be hooked up. So I'm gonna, you can see the old copper line. It's got to go not to the end of that copper line, but it's got to go to that that horizontal connection. It probably won't be as hard as it looks, but it's right now it's not looking. Right now it's not looking easy. But that's next phase. Maybe I'll just pop it off now, just to give myself an optimistic end to the day. Well, it's off. 2 feet down underneath the water meter. Very difficult to get to, but never mind. It's off. Got to put the new one on, and then sort out the new pipe. The good news is I managed to get the fitting off from this nasty, horrible place. The bad news is that it's not a big fitting. It doesn't surprise me. You see a big nut and you assume it's a big fitting, right? So the outside of the male end of the fitting that you can see is 1.5 inches. So I figured, wow, that is great news. This water meter supports a 1-inch pipe. And it sort of kind of does, except the restriction on the fitting is 1 inch, which means the inside is 3/4. And a good measure for me is my little finger can fit into a 3/4 inch hole. This is a 1-inch fitting. Nice tight fit on a little finger. This is a 1-inch pipe. When you actually look at what you get for 1 inch, so this is a 1-inch pipe, and of course it's 1 inch outside diameter. The inside diameter is only just a smidge bigger than 3/4. The inside diameter of a 1-inch coupling is a smidge less than 3/4. So it's worth not restricting the water coming into the house as best you can, and then choose where you restrict it and not accidentally put a 1/2 inch coupling somewhere. So 1 inch is what I go with going into the house, knowing that I actually get the full equivalent of a 3/4 inch pipe. And at 150 psi, which is what we have here, I need a pressure reduction valve because I have way too much pressure and flow, even at a tiny 1/2 inch pipe. Incidentally, not that it matters because I'm not using it, but a 1/2 inch pipe is much closer to actually 1/2 inch than the 1 inch is. Strange thing. It's kind of like, why is a 2x4 not 2 inches by 4 inches? Used to be, long time ago. All right, on with the job. Pipe is in the house. Pipe is in the trench. The trench is deep enough everywhere, and the pipe is on the fitting at the bottom of the hole. So it's 24 inches down. Everything's good, quite happy with that. So now to backfill and then go under the house to start the hooking it up to the system that I've already done. The new water service into the house is finished. More money spent on stuff. More fittings needed. So first thing that has to happen here is a pressure reducing valve. Apparently the pressure in the middle of town is between 150 and 200 psi. So that's a problem for many things. So pressure reducing valve, and of course it does not come with fittings for 3/4 or 1 inch or even 1/2 inch PEX. So you have to buy iron fittings. So that's a 1 inch iron adapter to then a 3/4 regular FMP thread for a PEX adapter. And then of course a 1 inch PEX to 3/4 thread, adapter before you get onto the PEX. So pressure reducing valve, $85. Yoo-hoo, that's not bad, not too terrible. Iron fitting, $15. PEX fitting, $10. And the other end, of course, $15, $10, right? And you back up to the $120 for the valve that comes with the different type of fittings. And it drives me crazy. But we now have pressure reducing valve, main shutoff, ball valve, and a drain for the system. I've made one small mistake, and that is that my shutoff valve won't shut off completely because I've rotated that in the wrong direction. So I'm just going to spin that out of the way so that the shutoff works nicely. This can be a drain valve or this can be a spigot in the basement. Either way, it's on the pressure, on the low pressure side of the reducer. as long as the main water is turned on. This works as either a spigot or, if the main water is turned off, as a drain. On the other end of the house, I will be putting a frost-free hydrant in for the outside at another time. So this is now complete. The water comes into the house in the way that it should. Everything's finished.